Okay, I think we have quorum at the table, and we have Dr. Bocchini at the microphone, so that's the perfect combination to get started with the HPV session.
John, thank you. So I'm here to introduce the HPV vaccine session for you. So first I'll review the work group activities. As you know, we've been preparing for licensure of the 9-valent HPV vaccine, and the potential licensure of that vaccine is late 2014. It's expected potentially to occur in December. We're also continuing to review data on the two-dose schedules. And as you remember, there was an ACIP presentation by Dr. Markowitz in June of 2014, which reviewed the data available on two-dose schedules for both of the licensed vaccines. Some background information to remind you about the investigational 9-valent HPV vaccine. This is a L1 viral-like particle vaccine similar to the quadrivalent HPV vaccine. It targets 5 additional high-risk types, which are here highlighted in red. The BLA was submitted to the FDA in December of 2013 for females 9 through 26 years of age and males 9 through 15 years of age. The trials that were submitted were conducted with a 3-dose schedule. The data on males 16 through 26 years of age was not part of the were not part of the BLA submitted in 2013. However, that data from those studies has now been completed and will be presented to ACIP today. The ACIP work group is reviewing data and considering policy options for presentation to the ACIP. As you know, we have a number of presentations on the investigational 9-valent vaccine made to ACIP. The first was in October of last year, in which an overview of the investigational 9-valent program was presented. In February, the burden of cancers and cervical precancers attributed to the HPV types in the United States was presented. And then the pivotal efficacy and immunobridging trials on the 9-valent vaccine were also presented. In June, the 9-valent HPV vaccine concomitant use trials, safety data, and revaccination study were presented to ACIP, as well as the first presentation of policy questions. For the two-dose schedules, we, as I mentioned, presented a comprehensive review of the data in June for both the bivalent and quadrivalent vaccines to discuss the World Health Organization decision about the two-dose schedules for young girls aged up to 14. But at the same time, we recognize that there's an intersection between consideration of a two-dose schedule for HPV2 and HPV4 vaccines with consideration that are being made for the result, as a result of the potential licensure of the 9-valent vaccine. There is no data available for the 9-valent HPV vaccine in a two-dose schedule. However, a study is underway which is expected to provide data within about a year, comparing a 3-dose to a 2-dose schedule for immunogenicity. So here's the outline for today's session. Dr. Elaine Luxembourg from Merck will present a summary of the 9-valent HPV vaccine program and new data, as I mentioned, for males 16 through 26 years of age. Dr. Mark Brisson will present the 9-valent vaccine impact data and cost-effectiveness study for the United States. Dr. Emiko Petrowski will present the grade evaluation on the 9-valent vaccine, and Dr. Lori Markowitz will then present policy considerations and options for initial discussion by the ACIP, with the expected potential for a vote in February. This slide shows the members of the HPV vaccine work group, and I want to thank everybody for their active participation. We've had a number of very important discussions leading to today, and I want to especially thank Dr. Markowitz for all her leadership and work on the work group as the CDC lead. So next, Dr. Luxemburg.
Good morning, everyone. So this is the third part of the presentation of the clinical program for the 9-valent vaccine. And we'll add some new data and also review all the data that have been presented before, because I understand that some member of the committee may not have seen all of it. Some abbreviation: 9V HPV vaccine, the 9-valent, Q HPV vaccine, the quadrivalent, the Gardasil licensed. And there are some standard abbreviation also for genital lesions, CIN being cervical precancer, VIN vulvar, vaginal, and so on. Just a brief summary about the rationale. The epidemiology has been covered in great detail. Worldwide, adding 5 new types will increase potential for cervical cancer for coverage from 70% with the existing types covered by the licensed vaccine to 90%. And this is not only for cervical cancer, it applies also to precancer, CIN2-3. There is also a substantial increase in coverage by adding 5 new types. That's what the epidemiology promises us, and so it's all potential. But there is a potential to prevent approximately 80% also the precancer, which could have really strong impact on decreasing procedures that are currently part of the cervical cancer screening algorithm. There are also now, these are worldwide numbers, so by country things may be slightly different, but every country will benefit. There are also now data available for non-cervical cancer due to HPV, so it's worldwide also, and there is a lot of research going on there, but it appears that also for other type of cancer, the 9-valent can contribute to increase coverage. And overall, we have a coverage that could be 85 to 95%, depending on the type of cancer. So the 4-valent vaccine is a licensed Gardasil. It's based on VLP. The adjuvant is aluminum-based. The 9-valent vaccine is manufactured the same way, using the same VLP as the 4-valent plus 5 additional VLP for additional types, and the same adjuvant. Doses of antigen and adjuvant have been adjusted to preserve immunogenicity and ensure high efficacy. And so, just as a reminder of what we were intending to accomplish, we had really 5 key goals in the 9-valent vaccine program. The first goal is with respect to the original types. We want to demonstrate that the 2 vaccines perform the same for the original types, because the intent is to for the 9-valent to gradually replace the 4-valent. So we want 2 vaccines that perform the same for what the 4-valent can do. The second objective is for the 5 additional types to demonstrate that there is a benefit and that the vaccine is highly protective. And then adolescents, which are a prime target population, cannot be studied for efficacy because they are not exposed to HPV. So bridging is through immunogenicity. We prove the efficacy in young women and we bridge to adolescents via immunogenicity. Men, the same thing, bridging the efficacy in young women to young men through immunogenicity. And finally, safety. So the 5 topics. And that was accomplished with 3 pivotal studies. We presented this data in February to the ACIP. Protocol 1 being the pivotal efficacy study in young women. Protocol 2 and 9 being immunobridging studies in adolescents. And a brief summary of the conclusion. We're not going to go through everything. It's just a refresher. All efficacy and immunogenicity objectives were met. For the original types, we demonstrated non-inferior response compared to the 4-valent vaccine. We also demonstrated similar protection against disease, very very few. The incidence of disease is very, very low in both vaccine cohorts. For the additional types, we demonstrated 97% protection against disease related to the additional types. And also we reported non-inferior immunogenicity in the adolescent population compared to young women. And also a safety profile that appears favorable. The only difference between the quadrivalent vaccine is a higher frequency of injection site adverse event, mostly mild to moderate in intensity. And we can go through a few data just also as a reminder. This is a demonstration of non-inferiority for the 4 original types. In white is a 9-valent cohort, is blue is a 4-valent cohort, and the GMT ratio are really close to 1. One type is a bit lower, one type is higher, 2 types are the same, but essentially we demonstrated non-inferiority. And looking at disease types, disease due to these types, so looking at HPV 16/18 related disease or disease related to the 4 types, you can see on this slide that there are very, very few cases. We're talking subjects have been followed for 3 to 4 years, and there is really no statistical difference in terms of incidence rates between the 2 groups. And looking at these same numbers, if we want to look at the historic Gardasil cohort, and these are the data in the Gardasil label. So you see the 9-valent cohort, and then you see the historic cohort from the Gardasil label. You can see that really the numbers are very low, compared to the historic placebo, where you would expect hundreds of cases, and in our study we didn't see anything. So it's supportive. It brings additional confidence that the 2 vaccine protects similarly against disease for the original types. Let's look now at the additional types, and we've already reported that there is high efficacy. These are the key efficacy endpoints: high grade cervical, vulvar, and vaginal disease. Cervical, vulvar, vaginal disease of any grade, or 6 months % infection, and the efficacy is uniformly between 96 and 97%. In terms of procedures, meaning biopsy, definitive therapy, we have also, a substantial risk reduction. Pap test was not shown on this slide, but there is also a substantial reduction, in the 90% range for Pap tests also. So these were the data. These were the efficacy data, and now the safety data. Just as a reminder that the safety profile of the 2 vaccines is very similar. The only difference being a higher incidence of injection site adverse events. Once again, mostly mild to moderate in intensity. So this was a reminder of the key data in the pivotal studies. We had also 3 more studies that were supportive, and the results were presented to this committee in June 2014. So 2 concomitant use studies. The one most relevant to the US is Protocol 5, using Menactra and Adacel. And then Repevax, which is a Tdap polio vaccine used in Europe, which is probably less relevant. And then a study in prior Gardasil recipients. And this is just a brief summary of the study to remind you that the finding indicates that the 9-valent vaccine can be administered concomitantly with Menactra and Adacel. So Menactra, meningococcal vaccine for serogroups, Adacel, a Tdap vaccine. And also that the 9-valent is highly immunogenic in prior Gardasil recipients. We've shown integrated safety in a database of over 13,000 subjects, and the vaccine appeared generally well tolerated across age, gender, race, ethnicity, profile similar to the quadrivalent vaccine, and generally well tolerated in prior Gardasil recipients. So these are the data you've seen. And today we have additional data to report, and these are data in men. This is the population that's missing. So far, we had data in boys 9 to 15 years of age, and girls and women 9 to 26 years of age. Now we add the boys and men 16 to 26 years of age. Just as a reminder, all the data we've shown so far are part of the original filing application with the FDA. The men data that you are going to see now are not part of that. So our plan is, as soon as, after we have hopefully this vaccine licensed, then it will be a second phase of submission. So let's go to the data. So Protocol 3 immunobridging study enrolled 1,100 young women, 16 to 26 years of age, and 1,100 heterosexual men, 16 to 26 years of age, and 300 men having sex with men, MSM. So you have these abbreviations, HM and MSM, that we are going to use, 16 to 26 years of age. Vaccine administered as for the other study of 3-dose regimen. It's an open label study. Everybody received 9-valent. And we looked at immunogenicity at month 7, 1 month after the last vaccination. Safety was followed for 12 months. And the objectives were to demonstrate non-inferior immunogenicity in heterosexual men 16 to 26 years of age versus women 16 to 26 years of age. You could ask me why are the MSM summarized separately? The reason is that in the quadrivalent program, so in the Gardasil clinical program, there was a finding that it was an incidental finding that the immunogenicity of the quadrivalent vaccine was lower in MSM than in HM. And we're talking HIV negative MSM. So the reason is not completely known, is not known, I should say. But it was not appropriate to introduce heterogeneity in an immunobridging study. So we summarized the MSM data separately. For the sake of time, I'm not going to have time to show you the MSM data, but if there are questions, I'm happy to answer. And then in terms of safety, summarize obviously the safety here. So immunobridging, this slide shows you in blue the men, in orange the women. It shows you that non-inferiority was met. Actually, the immunogenicity is numerically slightly higher in men than in women. For all 9 types, so it's a success, the study. So essentially it supports the bridging of efficacy finding in women to men. In terms of seroconversion, the seroconversion rates are also pretty high, nearing 100%, and there is also non-inferiority of the seroconversion rates. In terms of safety, these are a summary of vaccine-related adverse events, and for all adverse events, the frequency is lower in men than in women. There are no discontinuation due to serious adverse event, no vaccine-related serious adverse events, and no death in the program. And the fact that the safety profile appears slightly more favorable in men than women is very reminiscent of the safety profile of Gardasil, where there was also a similar finding. Okay, so summary slide. We've demonstrated non-inferior immunogenicity in young men compared to young women, which supports, once again, the bridging of efficacy finding to the men. And we demonstrated that the vaccine is generally well tolerated in young men versus young women. And as a summary slide to cover, to summarize everything that has been accomplished, and it's been a big effort, seven phase 3 studies. So we've demonstrated that for the original 4 types, we demonstrated non-inferior immune response with the 9-valent compared to the 4-valent. We demonstrated similar protection against disease endpoints. For the additional types, we demonstrated a strong protection against disease due to the additional types. We've demonstrated that all that was demonstrated in young women. We bridged the finding in young women to boys and girls and to young men via non-inferior immunogenicity. We reported that the vaccine is generally well tolerated, and now the safety database is over 15,000 subjects, adding protocol 3, 15,800 approximately. We've demonstrated that the vaccine can be co-administered with Menactra and Adacel, and it's generally well tolerated and highly immunogenic in prior Gardasil recipients. And as a note of caution, this is still an investigational product. It is under review by the FDA, and it should be treated as such. Thank you.
Thank you very much. I think we're going to move to the next presentation by Dr. Brisson, and then take questions at that time.
Good morning, and thank you for the opportunity to present today. The focus of my presentation is on the impact and the cost effectiveness of the 9-valent compared to the 4-valent HPV vaccine in the US. The modeling team that has produced these results are from Canada, but also from the UK through Marie-Claude Boilly and the CDC with Harold Chesson and Laurie Markowitz. I'd also like to thank the CDC internal peer review for valuable comments to this presentation. These are my conflicts of interest. I'd also like to state that the model was funded by a variety of sources from Canada, but also from the US, European Union, and the UK. So the study question that we were looking at is that from the societal perspective, what is the additional impact and cost effectiveness of the 9-valent compared to the 4-valent HPV vaccine in the context of an established 4-valent program in the US. So if we translate this into a scientific objective, the objective of this presentation is to evaluate the additional population level effectiveness and the incremental cost effectiveness of switching from the 4-valent to the 9-valent HPV vaccine in the US. So to do this, we used a model, and the model is called HPV Advise. It was developed to answer policy questions in Canada, but has also been used to look at 2-dose HPV vaccination in the UK and for the WHO. The model is an individual-based transmission dynamic model. Simply put, this model takes into account the direct effects of vaccination on vaccinees, but also takes into account herd immunity effects. We have 6 components in our model. We have a demographic component. We also model sexual behavior and HPV transmission, natural history of disease. We incorporate, obviously, vaccination, cervical screening and treatment, and we have an economic component. Our population is open and stable. What that means is that the number of individuals that come into the population is equal to the number of people that die of natural causes, and we have age-specific mortality based on US data. We also model 18 genotypes individually. So we have 18 HPV types in our model, including the 9 types in the 9-valent vaccine. We also model the various HPV-related diseases, anogenital warts, 2 types of cervical cancer, squamous cell carcinoma and adenocarcinoma, and we also model cancers of the anus, oropharynx, penis, vagina, and vulva. I won't go into detail of how we model the natural history of these, but we have slides in the extra slides explaining these. So in all of these models, the more complex they become, the more they might look like a video game. But for them to be really worthwhile for a public health decision, you have to calibrate and confront your model to actual data and find the appropriate parameters to represent the epidemiology and behavior of a population. So we go through an extensive calibration process that goes through 3 steps. For all of the parameters in our model, we do a systematic review of the literature to find the minimum and maximum value of each of these parameters. And then after, we sample hundreds of thousands of combinations of these parameters, and then we confront these, we put these parameter sets through the model, and we look and find those parameter sets that actually fit the US data. We fit to a lot of data, highly stratified data. Examples of these are we fit sexual and screening behavior stratified by gender and age, HPV prevalence stratified by HPV type, gender, age, sexual activity. We also fit to the incidence of anogenital warts, the lesions, cervical cancer, and the other HPV-related cancers, again stratified by HPV type, gender, and age. And in total, we fit our model to 826 data points. So the results of this is that we had 200,000 different combinations of parameters that were sampled and ran through our model. And from these, we found 50 parameter sets that produced a very good fit to the 826 data targets. So now once we have these parameter sets and they're reproducing the data in the US, we use them, we run them again through the model with vaccination to get our effectiveness. Examples of model fit are described. I'll show you a couple of examples of model fit. This is an example where we fit sexual behavior. So on the y-axis, you have the proportion of sexually active women by different age groups. The dots represent the data from the US, from NHANES, and the boxes represent the variability, the minimum and maximum of our model, our 50 parameter sets. We also fit HPV prevalence in women. Here's an example of how we fit HPV 16-18 prevalence by age and level of sexual activity. We fit screening outcomes such as the incidence of HSIL, and obviously we fit the cervical cancer incidence by age. So now we have a model that fits the situation in the United States, and now we want to see what the impact of HPV vaccination is. To do this, we need vaccine efficacy parameters. For 4-valent efficacy, we have two scenarios, and this is because in a systematic literature review that my team conducted, we found that the 4-valent vaccine was protected against the types in the vaccine, but there seemed to have some cross-protection to the other types in the clinical trial. We don't know how long this whether this is true cross-protection or how long it will last. So all of our predictions are with two scenarios, one with cross-protection, the other one without cross-protection. And obviously, this assumption can have an impact on the additional gains of a 9-valent vaccine. We assume that the 9-valent types are as effective as the 4-valent types, so the vaccine efficacy, type-specific vaccine efficacy is the same for the 9-valent and the 4-valent for type 16, 18, 6, and 11, and that it is 95% effective against the other 5 additional types. The economic analysis is from the perspective of the societal perspective. We include all direct medical costs. The primary outcome is cost per quality gained, and this is normally the primary outcome in cost effectiveness analysis. We use 3% discounting for both costs and benefits, and we look at costs and benefits, or accumulate costs and benefits over a 70-year time horizon. In terms of the cost of the vaccine, we assume that the cost of the 4-valent is $145 and the cost of the 9-valent is $13 more. And we base these numbers on a presentation that Merck did in 2014, where they were looking at the cost effectiveness of the 9-valent. So the way we go about looking at our predictions is that we want to model the US vaccine program as closely as possible. So we introduced vaccination in 2007, female only, with the quadrivalent. Then in 2011, we have gender-neutral vaccination with the 4-valent, and now we're in 2014. And there are decisions that can be made, either to continue with the 4-valent gender-neutral strategy, or to include or switch the program to 9-valent scenarios. We modeled 2 scenarios, a scenario where we vaccinate, or the US vaccinates girls only and maintains 4-valent for the boys, or a scenario where there is a complete switch from the 4-valent gender-neutral vaccination to 9-valent gender-neutral vaccination. To model the situation in the US as appropriately as possible, we use 3-dose vaccine coverage from US data, the National Immunization Survey. We used age-specific 3-dose uptake rates. What we mean by uptake rates is the annual percent of vaccinated individuals with 3 doses among those who had not previously received 3 doses. So for 2007 to 2013, we used the observed uptake rates And then from 2014 onwards, we assume that uptake rates are constant at 2013 levels. And this means, if we look at the figure, that in 2013, we reproduce what the data is for the coverage of 13 to 17-year-olds, which is about 39% for girls and 14% for boys. If vaccine uptake rates remain constant, then vaccine coverage increases slightly until 2017 due to age and time course effects. Before I go into the model predictions, I wanted to give you an appreciation of what is the potential for additional cancer prevention by adding 5 types to a vaccine. So on the y-axis, you have HPV type-specific positivity for the different cancer sites in women and men. The gray area is the contribution of 1618, and the blue area is the contribution of the additional 5 types. What you can see here is that most of the cancers are due to 16 and 18, which are already in the 4-valent vaccine, but there are opportunities for additional gains. But when we do cost effectiveness and when we look at the impact of a vaccination program, we have to look at the number of cases per year that we could be preventing. So on this figure, we have the number of cases per year for the different cancer sites. And you can see that where there would be the greatest gain from a 9-valent vaccine would be by additional prevention of cervical cancer. Now, for model predictions, I'll go a bit more slowly on this slide because a lot of the slides look like this one. So this is a scenario where we're looking at a 4-valent girls and boys vaccination and compared to a 9-valent gender-neutral vaccination under our base case assumptions and assuming no cross-protection for the 4-valent. On the y-axis, you have percent change in incidence, and on the x-axis, you have time since start of vaccination, and the 2 outcomes are SIN2-3 and cervical cancer. The red line represents the predicted reduction in the outcome following 4-valent vaccination, and the blue line represents the predictions for the 9-valent, and the dashed lines between those 2 lines represent the added benefit of a 9-valent compared to the 4-valent. What we predict with our model is that with a 4-valent vaccine, there would be substantial reductions in SIN2-3 and cervical cancer to about 61% for SIN2-3 and 65% for cervical cancer. By switching to a 9-valent vaccine, there would be an additional 19% reduction in SIN2-3 and 14% reduction in cervical cancer. Now, we have to also look at the scenario where there could be cross-protection, and this is what this slide is showing. So I've added a line, and that is the dotted red line where we have 4-valent girls and boys vaccination with the cross-protection, and now the dashed line is the added benefit from a cross-protection vaccine, a 4-valent vaccine to 9-valent. You see that the benefits are a bit lower, so we go from 19% to 12% for SIN2-3 and from 14% to 10% for cervical cancer. So there are still substantial gains, even if we assume cross-protection. Now, another question is, if we go from a 4-valent gender-neutral strategy and switch only girls to the 9-valent, what would happen? And that is what the dotted blue line is representing. And you can see that the dotted blue line is very close to a switch to a 9-valent for the boys and girls strategy, meaning that most of the benefit of a switch from the 4-valent to the 9-valent gender-neutral strategy would be because the US would be vaccinating girls with the 9-valent. So there are other benefits to the vaccine than cervical lesions and cervical cancer. What this slide is supposed to show is that the additional benefits of the 9-valent are a bit smaller for the other HPV-related outcomes, and this is to be expected. So on the left-hand side, we have the impact on oropharyngeal cancer, and on the your right-hand side, the impact on anogenital warts. No impact on anogenital warts because we assume that the 4-valent and the 9-valent have the same efficacy for the 2. The oropharyngeal cancer, you have a slight increase in benefits by vaccinating with the 9-valent. And this added benefit is quite similar to the other cancer sites. Now, there are different ways of looking at the overall impact of vaccination. I just wanted to show it in a different way. And here we're showing health outcomes prevented over 70 years for the different scenarios we've been talking about. So on the y-axis, you have the number of events averted. The events here are all HPV-related cancers or deaths due to cancer. Now, here what we're showing is what would be the added benefit of going from a vaccine program of no cross-protection 4-valent to a 9-valent girls and boys strategy. Well, what our model predicts is that there would be an additional 87,000 cancers prevented over 70 years. And this would relate to, in terms of number needed to vaccinate, of 1,000, meaning that one additional cancer case would be prevented for every, on average, for every individual that would switch, every 1,000 individuals that would switch from the quadrivalent to the 9-valent. In terms of cancer deaths, we predict that there would be 26,000 cancer deaths, additional cancer deaths prevented by switching to the 9-valent. The additional benefits are lower with if we assume cross-protection. So with cross-protection, the NNV increases, but the number of cases prevented is reduced. So we predict 47,000 cancer cases prevented and 14,000 deaths. Now again, what this slide shows is the added benefit going from 9-valent in girls, 4-valent in boys, to 9-valent in girls and boys, and the added benefit is quite small. So what does this mean in terms of cost effectiveness? Well, in cost effectiveness, the main outcome for benefit is QALYs gained. So this shows the incremental QALYs gained discounted over 70 years for different strategies. So on the y-axis, you have the incremental cost, the incremental QALYs gained for the different strategies. The different colors represent the contribution of the different outcomes to the overall QALYs gained. So if we look at the first histogram, the main benefit in terms of QALYs gained of going from of vaccinating with the 4-valent is prevention of cervical cancer and prevention of the other HPV-related cancers. Now, if we compare switching girls to a 9-valent and maintaining boys with a 4-valent, then their incremental benefits are smaller, but that's understandable. But what I wanted to point out is that the main benefits here are really in the prevention of cervical cancer. And finally, going from strategy 3 to 2, so having a gender-neutral 9-valent compared to having the 9-valent only in girls, the incremental benefit is small. Now, this is the slide on the cost side where we look at the incremental cost savings from vaccination. And if we look at 4-valent vaccination, the main savings in terms of cost to the healthcare system is in preventing or in costs related to cervical screening. If we compare 9-valent girls, 4-valent boys to 4-valent girls and boys, the main savings in costs are due to cervical screening, and then there are very little gains when we're going from 9-valent girls to 9-valent girls and boys. So now when we look at the ratio of all of this, we get the cost effectiveness ratio. This first table shows the cost effectiveness assuming no cross protection for the 4-valent vaccine. I want to draw attention to this first result, which is the cost effectiveness of the 4-valent compared to no vaccination. We estimate that that vaccination would be highly cost effective, 6,400 per QALY gained. We also, below that number, we have a uncertainty interval, and that uncertainty interval represents the 10th and 9th percentile of model results based on our 50 best parameter sets. So this represents our uncertainty around our prediction, but still the predictions are that 4-valent vaccination is very cost effective. Now, if we go from 4-valent vaccination to 9-valent girls, 4-valent boys, it is cost saving. So by switching to a 9-valent program, there would be cost savings. And the majority of these cost savings would be in the prevention of the costs related to cervical screening. Okay. Now, I've shown you that the incremental benefits and incremental costs are quite low if we go from the 9-valent girls to 4-valent boys to a gender-neutral 9-valent vaccination. But still, we get a cost-effectiveness ratio of around 31,000. But we have a lot of uncertainty around that cost-effectiveness ratio. It goes from very cost-effective to not cost-effective at all. So there's a lot of uncertainty into that. But what there is less uncertainty about is that it would be cost-saving going from a 4-valent girls and boys strategy to a 9-valent girls and boys. The results are quite similar. I won't go into detail because of time, but the results are quite similar when we assume cross-protection instead of no cross-protection. Now, we wanted to see how robust our results were to changes in key parameters. So we varied certain parameters and looked at their impact. In fact, our model was very robust and predictions were very robust to our sensitivity analysis. But what we did is we varied the duration of vaccine efficacy, and it did not make a big difference on our results. We changed vaccine coverage, higher coverage, and we also looked at a scenario where all three, a high proportion of 13-year-old girls and boys would be vaccinated at 13 instead of the older ages. We looked at also a scenario where we included in the model all the minimum cost to the healthcare system, meaning that it's a scenario where the cost related to screening would be very low, and even at that, the switch to a 9-valent was cost saving. And we, in our base case, we model primary screening as cervical screening. We wanted to look at what would happen with the current or changes to screening guidelines. So we looked to see whether with co-testing, so HPV co-testing for women that were 30 to 65 years of age, whether that would make a difference on our results. And even with co-testing, the switch was cost saving. And if we look at the same table, but assuming cross protection, we again the results were very insensitive to changes in key parameter values. Now, one parameter that is very important in all cost effectiveness analysis, and that's obvious, is the cost of the intervention. So here is the cost of the vaccine. So in this slide, what we wanted to show is on the y-axis the cost per quality gain as a function of the differential cost between the 9-valent and the 4-valent. The red dot represents the base case scenario. The solid blue line represents our predictions, our average prediction of the 50 parameter sets, and the dotted line represents the uncertainty, our model uncertainty around that base case value. So if we look at the no cross protection figure, the assumption was that the cost difference was $13. At $13, all of our scenarios were cost saving. If we look at the cross protection scenario, most of our simulations were showing cost per quality gain that were negative. So that means that most of our scenarios again were cost saving. However, if the additional cost per dose is higher than $13, if it increases, then quite rapidly the cost per quality increases. So in all modeling and cost effectiveness exercises, there are limitations, and there are always many limitations in modeling. So I'm trying to point out three main sources of the limitations. The first one is that duration of the 4 and 9-valent vaccine efficacy and the future vaccination coverage in the US remains unknown. However, we varied duration of protection and vaccine coverage, and these parameters had no real impact on conclusions. We also modeled both cytology-based screening and HPV co-testing. But screening may change in the upcoming years. For example, there might be primary HPV testing that might be considered. If the changes to the screening result in less costly or more effective cervical cancer prevention, then 9-valent cost effectiveness might be lower. And finally, we did not present cost effectiveness of the 9-valent compared to the 2-valent because that's not the strategy being used in the United States. But we looked at this strategy in Canada, and the 2-valent vaccine was less cost effective than the 9-valent and the 4-valent with the prices we assumed in our analysis. So in summary, in terms of the population level effectiveness predictions, current US 4-valent gender-neutral strategy is expected to substantially reduce HPV-related diseases. Switching to a 9-valent gender-neutral strategy is expected to further reduce precancerous lesions and cervical cancer with less impact on other HPV-related outcomes. And importantly, vaccinating girls with the 9-valent provides the great majority of benefits of a 9-valent girl and boy program. In terms of cost-effectiveness predictions, current US 4-valent gender-neutral strategy is highly cost-effective. Switching to 9-valent gender-neutral strategy, a strategy program is likely cost-effective and even cost-saving. And these results are robust across a range of plausible assumptions, including or not cross-protection, varying price, but not to extreme levels, duration of protection, healthcare costs, and burden of illness. So thank you very much.
Thank you much for a very nice presentation there. I think we're open for any questions from the committee or liaisons. Dr. Ernstein.
One question I think that will likely to come up in policy making deals with what to do with persons who are already fully vaccinated against the 4 types. And I'm wondering if you've looked at all what the cost or effectiveness is of whether to go back to people already vaccinated against the 4 and give them additional doses to protect against the additional 5.
And so that's a very good question, and I have extra slides looking at this. So thank you for the question. It's an exploratory analysis. So we looked at what would be the cost effectiveness of revaccinating 13 to 17-year-old females who have already received 4-valent, 3 doses of the 4-valent. And the incremental cost effectiveness ratio that we got was 88,000, ranging from 52 to 300. So there was a lot of variability in this. I have to point out that there were important assumptions that were made here that all made the cost effectiveness look better than reality. There's no, in this scenario, there's no herd effects of the 9-valent from the women that received the 9-valent. So basically, what I want to say is it's an exploratory analysis. This result is quite conservative. So if we look at revaccinating older women, it would not look cost effective, or revaccinating boys, it would not be cost effective. But here we're in a gray zone.
And in follow-up to that, is that using a 2 additional doses?
The question...
Or 3 additional doses on top of, for the revaccination of people already receiving 3 doses of the quadrivalent.
Okay. So the assumption here is that there are 3 doses of 9-valent given to those who've already had 3 doses of 4-valent. Sorry.
Thank you. Dr. Lair.
Could you go to slide 38, please?
Yes.
I guess they're labeled differently. I was actually looking for the cost effectiveness table.
Oh, the cost effectiveness table. Sorry, yes. Okay.
Oh, sorry. I'm not sure what the 1 versus 0 and the 3 versus 2 column is supposed to represent.
Okay. So I don't know if I have a laser. Do I have a pointer? It's there. So the question is, So
The,
basically,
that column, is that the number of doses that they're receiving?
okay, so the way to look at this, and I went quite rapidly, sorry. So the way this column here is just to explain what the comparator is. So here we're comparing the 4-valent girls and boys to no vaccination, which is the 0. And for this one, for example, it would be this scenario compared to 4-valent vaccination. And we have 2 comparators for the 9-valent girls and boys. Either we compare it to this strategy, where girls only would be vaccinated with the 9-valent, and we would have a comparator where it would be switching, going from here to here. Now, if we look at the columns, these are the changes in cost in millions of dollars. And this includes the cost of the vaccine, but all of the cost offsets. These are the quality gain, and this is basically this divided by that.
Thank you.
At the microphone.
Hi, Tom Weiss with Merck. As was alluded to, we also have our own model that was presented at a recent HPV Congress and to the working group, and we found very similar results and reached very similar conclusions as well. Thank you.
I don't want to put you on the spot, but with you at the microphone, how likely is the price that was used in the modeling to be what we see in the future?
The price has not been determined yet, and that will be announced at the time of licensure.
Thank you very much. Other comments or questions? Yeah, Dr. Schuchat.
Just because somebody mentioned price, I want to say this. The price at licensure that's announced may not be the price over time. And on the CDC's website, we post the VFC prices, and they get updated when the price changes. So the price has not been stable since the original licensure.
Thank you. Any other comment on, Dr. Lanja?
Just to follow up on Dr. Schuchat's comment, so do they generally go down afterwards? And
The price has gone up
it's gone up.
annually.
Dr. Reingold. Okay. Dr. Sun.
I just want one clarification. So in the modeling, did you, and I may have missed it, but did you take into account potential for indirect effects or herd immunity?
Yes, yeah. This model takes into account all of the partnership formation and separation, and so we model sexual behavior, we model transmission of HPV, and we also model therefore the indirect effects of preventing someone from being infected on others. So if a woman is prevented from having HPV, she's also not transmitting the HPV to her male partner or partners.
Yeah, Dr. Hans, or Dr. Kissinger.
Hi, thanks. I just had a question about the drop in screening costs, and does that refer? That doesn't refer to the initial screening. That are you suggesting that's fewer costs because of less abnormal lesions that need to be followed up?
Yeah.
So it's not, you're not saying that there would be no screening. You're just saying there would be less follow-up of abnormal lesions from the screening.
Yeah, thank you for that position. Yeah, so the costs that are being saved, the screening costs that are being saved, are mainly due to the fact that there are less costs to follow up in management of abnormal lesions.
Okay, all right. Thank you.
And Dr. Reingold.
So that's very elegant. Thank you. My question isn't for you. My question is for the clinicians in the room. And I'm just wondering in terms of the sort of the picture in the average clinician's office with one vaccine for boys and a different one for girls, just in terms of storage and confusion and whatever. I'm just wondering how practical that is, thinking that girls would get the 9-valent and boys would get the 4-valent.
I guess in follow-up to that, too, if we can get some comment from Merck on this, but but would you continue making both vaccines, or would it be very akin to the PCV or 7 to 13 situation? And Dr. Markowitz.
Maybe we can discuss some of this when we get to the options that were considered by the work group. I think that might be. Yeah.
It does look like we have a comment here, though.
Hi, I'm Julie McCafferty from Merck. We intend to supply both products. We anticipate there'll be demand within the U.S. for both until there's a time when the indications for Gardasil and the 9-valent match. We would then allow time for series completion. We will still also manufacture for outside the U.S.
Thank you. And it looks like the time is probably ripe for moving on to the next two presentations. So if we can have Dr. Petrosky.
Good afternoon. The HPV work group used grading of recommendations, assessment, development, and evaluation, or GRADE, to review data related to the 9-valent HPV vaccine. The 9 steps of GRADE are shown here. The previous presentations included an assessment of the population benefit and a review of the health economic data for the 9-valent vaccine. My presentation will cover the first 4 steps of GRADE. The remaining steps will be completed at the next ACIP meeting in February. The first step in GRADE is to develop the policy questions. The questions that I'm going to address during my presentation are: should the 9-valent vaccine be recommended routinely for 11 or 12-year-olds? And should the 9-valent vaccine be recommended for females aged 13 to 26 years and males aged 13 to 21 years who have not been previously vaccinated? The next step in GRADE is to consider critical outcomes. This table shows the outcomes the work group identified and ranked, and whether or not they were included in the evidence profile for GRADE. The benefits are listed separately for females and males, and the harms are listed jointly. In red are the outcomes we did not include in our evidence profile. We did not include definitive therapies, since they are represented by cervical precancer and cervical cancer, or oropharyngeal cancer, as there are no data for this outcome from any HPV vaccine study. For simplicity, we also did not include vaginal vulvar cancer and anal cancer in the evidence profile for females, instead focusing on the most prevalent outcomes in women: cervical precancer, cervical cancer, and anal genital warts. For males, we assessed anal cancer and anal genital warts, and for harms in both females and males, we assessed serious adverse events and anaphylaxis. The next step in GRADE is to review and summarize the evidence of benefits and harms, which we performed after reviewing published and unpublished data relevant for the 9-valent vaccine. But before I present the data, there are a few considerations I'd like to mention. Both the 9-valent and quadrivalent vaccines are recombinant HPV, virus-like particle, or VLP vaccines, with the same manufacturing process, and both contain HPV 6, 11, 16, 18 VLPs, the 4 original types. The 9-valent vaccine contains 5 additional VLPs. The 9-valent vaccine program compared the 9-valent vaccine to the quadrivalent vaccine as the active comparator. However, because the quadrivalent vaccine is highly efficacious, there were few disease endpoints due to the 4 original types in the comparator cohort, and the efficacy of the 9-valent vaccine for the 4 original types could not be directly assessed. Instead, the 9-valent vaccine was immunobridged to the quadrivalent vaccine to demonstrate non-inferior immunogenicity and comparable efficacy. Because of this, data from the quadrivalent vaccine trials were considered for the 4 original types for GRADE of the 9-valent vaccine. Of note, neutralizing antibody is considered the mechanism of protection for HPV vaccination, and the vaccines induce high antibody titers. However, no minimum level of protective antibody has been identified. This table shows the quadrivalent phase 2 and 3 efficacy RCTs submitted for quadrivalent vaccine licensure. that were considered for grade of the 9-valent vaccine for the 4 original types. In females, there were 3 RCTs, and in males, 1 RCT, comparing the quadrivalent vaccine to placebo. As I mentioned earlier, the 9-valent vaccine, represented here by the green boxes, was immunobridged to the quadrivalent vaccine, represented by the purple boxes. All of the data examined for grade involved the per-protocol population from these studies. Of note, although the age groups in these studies do not completely correspond to the age groups in our policy questions, they do closely overlap. Protocol 1 is the pivotal efficacy study that compared the quadrivalent vaccine to the 9-valent vaccine in females aged 16 to 26 years. Protocol 2 compared the 9-valent vaccine in females aged 16 to 26 years to females and males aged 9 to 15 years. Protocol 3 compared the 9-valent vaccine in females aged 16 to 26 years to males of the same age group. And Protocol 9 compared the quadrivalent vaccine to the 9-valent vaccine in females aged 9 to 15 years. Not shown in this diagram are the concomitant use studies, Protocol 5 and 7, which provide additional supportive evidence of 9-valent vaccine immunogenicity and safety. I'll now review and summarize the evidence of benefits, first focusing on the population of females aged 13 to 26 years. The intervention is the 9-valent vaccine, and the comparison group is the quadrivalent vaccine. We examined the outcomes by vaccine type, the 4 original types and the 5 additional types as shown here. I'm presenting the evidence in older females first, as vaccine efficacy can only be demonstrated in older age groups. Efficacy findings are then immunobridged to the younger age groups, which I'll present later. The quadrivalent vaccine trials showed high efficacy. In females, the vaccine demonstrated greater than 98% efficacy in preventing CIN-2-3, or AIS, due to the 4 original types, and greater than 98% efficacy for anal genital warts. In the next series of slides, I'll present the data from the study, immunobridging the quadrivalent vaccine to the 9-valent vaccine in older females. This table shows the outcome data from Protocol 1, presented as the incidence of outcomes in the 9-valent vaccine group compared with the quadrivalent vaccine group. For the 5 additional types, also shown are vaccine efficacy, absolute risk difference per 1,000, and number needed to vaccinate. For outcomes due to the 4 original types, the 9-valent vaccine demonstrated comparable efficacy in preventing cervical precancer and anal genital warts. For the 5 additional types, the 9-valent vaccine demonstrated greater than 96% efficacy in preventing cervical precancer, and the absolute risk difference was 4 fewer cases per 1,000. The number needed to vaccinate was 250. Based on the dynamic model of HPV vaccination shown previously by Dr. Brisson, 1 case of CIN-2-3 due to the 5 additional types is prevented for every 51 to 76 females vaccinated with the 9-valent vaccine instead of the quadrivalent vaccine over a period of 70 years. This table shows the seroconversion data from Protocol 1 for the 9-valent vaccine compared with the quadrivalent vaccine in older females. For all types, there was greater than 99% seroconversion with the 9-valent vaccine. There was no difference for the 4 original types compared to the quadrivalent vaccine. And this table shows geometric mean titers, or GMTs, from Protocol 1. For the 4 original types, the 9-valent vaccine induced non-inferior GMTs compared with the quadrivalent vaccine. And for the 5 additional types, superior GMTs compared with the quadrivalent vaccine. The next step in grade is to evaluate the quality of evidence. This table shows the evidence type ranking used for grade. The highest type is 1. This includes RCTs, or overwhelming evidence from observational studies. The lowest type is 4. For grade of the 9-valent vaccine, we began all of our evidence types with 1, based on starting with either the RCT of the quadrivalent vaccine or the RCT of the 9-valent vaccine. I'll now present the evidence type for the benefits due to the 4 original types in older females. The outcomes are listed in the leftmost column, followed by study design and number of studies, and the criteria that were used to grade the evidence type. Because the 9-valent vaccine was immunobridged to the quadrivalent vaccine, we graded the quadrivalent vaccine trials and considered data from the 9-valent vaccine studies as supportive evidence. The quadrivalent vaccine trials were RCTs without notable limitations, so we began each outcome with an evidence type of 1. Starting with cervical precancer, we downgraded by 1 for indirectness due to the use of immunobridging to the quadrivalent vaccine, resulting in an evidence type of 2. For cervical cancer, we also downgraded, again for indirectness, due to the use of cervical precancer as a surrogate marker for cervical cancer, resulting in an evidence type of 3. For anal genital warts, we downgraded by 1 for indirectness, again for the use of immunobridging data, resulting in an evidence type of 2. For the 5 additional types, we graded Protocol 1, the RCT that compared the 9-valent vaccine to the quadrivalent vaccine in older females, as this study was able to demonstrate 9-valent vaccine efficacy for the 5 additional types. For cervical precancer, we did not downgrade for any criteria, which kept the evidence type at 1. For cervical cancer, we only downgraded by 1 for indirectness, again due to the use of cervical precancer as a surrogate marker for cervical cancer, resulting in an evidence type of 2. Now turning our attention to the younger females, the population is females age 11 to 12 years, and similarly to older females, we examined the outcomes by the 4 original types and the 5 additional types as shown here. In the interest of time, for this and the remaining populations, I will not be presenting the data for the benefits, as these have been previously presented to the ACIP. I will instead focus on the process we use to grade the evidence and explain our approach for evidence type ranking. Shown here are the supportive studies we considered for grade for the 9-valent vaccine in younger females. Protocol 2 was an immunobridging study that showed the 9-valent vaccine induced non-inferior seroconversion in higher GMTs in younger females, which supports the bridging of efficacy findings in older females to younger females. Protocol 9 showed that the 9-valent vaccine induced non-inferior seroconversion in GMTs compared to the quadrivalent vaccine in younger females, which supports the bridging of efficacy findings from the quadrivalent vaccine to the 9-valent vaccine. So for the younger females, we started with the evidence type for the older females and did not downgrade for any criteria, keeping the evidence type the same. This is because of the high seroconversion rates and higher GMTs in the younger females compared to the older females, and because the efficacy data were from the per-protocol population. I'll now summarize and evaluate the evidence for the 9-valent vaccine in males. First, in the population of males aged 13 to 21 years. We only assessed the outcomes due to the 4 original types because of the low burden of disease due to the 5 additional types in males. In Protocol 020, the quadrivalent vaccine efficacy trial in males, the quadrivalent vaccine demonstrated greater than 74% efficacy for prevention of AIN23 and greater than 89% efficacy for prevention of anal genital warts. This slide shows the studies we considered for grade for the 9-valent vaccine in older males. Once again, we started with the quadrivalent study and considered the data from the 9-valent study, Protocol 3, as supportive evidence. Of note, grade for the quadrivalent vaccine in males was presented to the ACIP in 2011. A link to the policy statement and the grade tables is provided in the footnote below. Based on Protocol 020, efficacy for prevention of anal cancer had been ranked in evidence type of 2, and anal genital warts in evidence type of 1. There is no study in older males immunobridging the 9-valent vaccine to the quadrivalent vaccine. Instead, there is Protocol 3, which immunobridged the 9-valent vaccine in older females to older males. The 9-valent vaccine induced non-inferior seroconversion in GMTs in older males, which supports the immunobridging of outcome findings in older females to older males. This table shows the evidence type for the benefits of the 9-valent vaccine in older males. Starting with the evidence type of 2 for anal cancer and 1 for anogenital warts, we downgraded both outcomes for indirectness due to the use of immunobridging data, resulting in evidence type of 3 for anal cancer and 2 for anogenital warts. Now focusing on the population of males aged 11 to 12 years, similarly to older males, we only assessed the outcomes due to the 4 original types. One of the supported studies was Protocol 2, which immunobridged the 9-valent vaccine in older females to younger males. The 9-valent vaccine induced non-inferior seroconversion and higher GMTs in younger males, supporting the bridging of efficacy findings from older females to younger males. In addition, we compared the GMTs in younger males from this study with GMTs from older males in Protocol 3. The younger males had higher GMTs compared with the older males, which once again supports immunobridging from older males to younger males. Thus, for the younger males, we started with the evidence type for the older males and did not downgrade for any criteria, keeping the evidence type the same. Again, because the younger males had higher seroconversion rates and higher GMTs than the older males, and because the efficacy data were from the per-protocol population. Now switching to harms, the outcomes under consideration are serious adverse events, or SAE, which we examined as day 1 through 15 after vaccination and any time during the study period, and anaphylaxis day 1 through 15. We examined the harms by older and younger age groups. First, focusing on harms in older females and males, there was 1 RCT and 2 observational studies that assessed harms in the older age group. The adverse events were similar for the 9-valent vaccine and the quadrivalent vaccine. There were few cases of vaccine-related SAEs in either group, and only 1 case of anaphylaxis with the 9-valent vaccine, which was determined to be due to a non-study medication. In terms of the evidence type for the harms, due to the 9-valent vaccine in older females and males, we started with an evidence type of 1 due to inclusion of an RCT. For both SAE and anaphylaxis, only imprecision was downgraded due to the small sample size, resulting in a final evidence type of 2. For the younger age group, there was 1 RCT and 3 observational studies that assessed harms in the younger age group. Once again, the adverse events were similar for the 9-valent vaccine and the quadrivalent vaccine. There were few cases of vaccine-related SAEs in the 9-valent vaccine group, and for the younger age group, no cases of anaphylaxis in either group. The evidence types for harms of the 9-valent vaccine in younger females and males were similar to the older age groups. The initial evidence type once again was 1 due to inclusion of an RCT, and once again for both SAE and anaphylaxis, only imprecision was downgraded due to the small sample size, resulting in a final evidence type of 2. I'll now summarize the findings and the overall quality of evidence for the 9-valent vaccine by the populations I just presented, starting with older females. Once again, the quadrivalent vaccine trials showed high efficacy for the quadrivalent vaccine, and the 9-valent vaccine demonstrated non-inferior immunogenicity and comparable risk for the outcomes due to the 4 original types. For the 5 additional types, we graded the RCT, comparing the 9-valent vaccine to the quadrivalent vaccine, which showed a decreased risk for the outcomes due to the 5 additional types. For harms, there were a few cases of SAE and no vaccine-related anaphylaxis. So taking into consideration the evidence types for all 9 types combined and the supportive 9-valent vaccine studies, we gave the overall evidence for benefits and harms in older females a final ranking of 2. In younger females, the 9-valent vaccine demonstrated non-inferior immunogenicity, and the evidence types are the same as was shown for older females in the previous slide. For harms, there were no serious adverse events and no cases of anaphylaxis. In older males, the quadrivalent vaccine trial showed high efficacy for the quadrivalent vaccine, and the 9-valent vaccine demonstrated non-inferior immunogenicity for the 4 original types. The harms are the same as for the older females. For older males, because there is no immunobridging study comparing the quadrivalent vaccine to the 9-valent vaccine in males, we gave the overall evidence type for the benefits and harms a ranking of 3. Finally, in younger males, the 9-valent vaccine demonstrated non-inferior immunogenicity, and the evidence types are the same as was shown for older males in the previous slide. Once again, the harms are the same as for the younger females. In conclusion, the overall evidence type for older and younger females was 2, indicating moderate confidence. For the older and younger males, the evidence type was 3, or of low confidence. I'd like to acknowledge the individuals listed on this slide and the HPV workgroup for their help with this presentation. Thank you.
Thank you much. Dr. Markowitz, did you want to come up and do your section and then take questions? Pardon? If there are specific questions to the grade, we could take those. Oh, Dr. Gorman.
In terms of the indirectness of the data from CIN to cervical cancer, aren't there natural history studies that can give us a percentage of those that progress and those that resolve spontaneously that should allow us to make that a not a downgrading factor?
Not sure. I'm not familiar with the natural history studies. And
Natural history studies, I think, were in the late 90s, which led to the recommendations for the present therapeutic interventions for those with the, and forgive me for not being a specialist in this particular area, but that was where we decided that they needed treatment because of we had a percentage that progressed and a percentage that regressed.
Yeah, I think that's a good point. We were being very conservative in counting those as indirected. We did we didn't downgrade, obviously, for prevention of the precancer lesions themselves. Those were not downgraded, but we have been very conservative in considering precancer a surrogate for cancer. And that's, I think, generally what people have been considering, both regulatory agencies and worldwide.
Thank you. Why don't you go ahead, Dr. Markowitz?
Mm-hmm. So for this last session, I'd like to review issues and considerations for HPV vaccination recommendation options that have been discussed by the work group. The policy issues over the next year for HPV vaccine are going to be impacted, as you've heard, by the expected licensure of the 9-valent vaccine, but also status of data on 2-dose schedules. And for both of these issues, we'll have to consider the evidence base as well as programmatic and regulatory issues. So this is just an overview of my presentation. And before I talk about policy issues, I'm going to give a brief review of vaccine coverage in the U.S., then give a very brief overview of data on 2-dose schedules that were presented at the June ACIP meeting, and then finally discuss considerations and options discussed by the work group. So first, looking at coverage, I think everyone has seen this slide many times. This shows national estimated vaccination coverage among adolescents 13 to 17 years in the U.S., and you can see that coverage for Tdap and meningococcal conjugate vaccine has increased over time from 2006 to 2013, reaching about 80%. And the coverage for greater than or equal to 1 dose and 3-dose HPV vaccine initially increased in parallel, but then plateaued. And there was a small increase between 2012 and 13, but this was small. And in 2013, 1-dose coverage was 57% and 3-dose coverage was 38%. And this shows the data in males. That increased after the recommendation in 2011. And in 2013, 3-dose coverage was 35%. And I'm sorry, 1-dose coverage was 35%, and 3-dose coverage was 14%. Now, overall, about 70% of those who start the vaccination do receive all 3 doses. This slide shows at least 1, at least 2, and all 3-dose coverage in the U.S. As you can see, the lines are fairly parallel, and the drop-off between 1 and 2 and 2 and 3 is about the same. So 1-dose coverage, 57%, 2-dose, 47%, and 3-dose, 38%. I think, again, most people know that there are ongoing efforts to try to increase coverage in the U.S. This includes materials to assist providers. There's been special funding awarded to many project areas to look at communication, education, elimination of business opportunities, and also partnerships with other organizations. Now, what is happening so far in 2014? We don't really have data on that because we get NIS data next year sometime, but we did look at doses distributed, cumulative doses distributed over time, and this slide shows doses distributed in 2012 and 2014. And what you can see here is that there was an increase between 2012 and 2013, which may reflect the increase in coverage we saw in NIS-Teen. But so far in 2014, the number of doses distributed seems to be very similar to what it was last year. I'd like to give very briefly a review of two-dose schedules. And at the last meeting, we reviewed data on trials of alternative and two-dose schedules. We talked about regulatory approvals and recommendations, and also reviewed data from countries using two-dose schedules, and then considered considerations for the U.S. Again, this is a very brief review of the data we reviewed at the last meeting. Most of the data on two-dose schedules are from immunogenicity data, and these studies have shown very high seroconversion rates with 2 doses and geometric mean titers that are non-inferior after 2 doses given at 0 and 6 months in females 9 to 14 compared to 3 doses in females who were 16 to 26-year-olds who received the traditional 3-dose schedule. There also is data from a post-hoc analysis of a 3-dose randomized controlled trial of the bivalent vaccine that found high efficacy for 2 doses. And then there's a variety of data from effectiveness studies. These are post-licensure studies, and in general, they have found lower effectiveness for 2 versus 3 doses for a variety of outcomes. However, these studies have many limitations, and one of them is that the 2-dose recipients did not receive a 0-6-month schedule. They were persons who were supposed to receive the 3-dose schedule that did not complete it. And second, there could have been confounding in these studies due to differences between the 2-dose and 3-dose recipients. Now, as I said, most of the data from the immunogenicity studies on 2 doses are from immunogenicity studies, and this slide shows the studies that are available, and we reviewed these in June. These are 3 studies of the bivalent vaccine in the top half of the slide and 2 studies of the quadrivalent vaccine. 4 of these studies were immunobridging studies that compared 2 doses in the younger age group with 3 doses in the older age group, the age group that in which efficacy was demonstrated in the efficacy trials. These 2 studies that I've highlighted here were included in the submissions for licensure that GSK submitted for the bivalent vaccine in a variety of countries, and there was 1 study that was included in the submissions for the quadrivalent vaccine in some countries. Because we were primarily using the quadrivalent vaccine, I want to mention a little bit more about this 1 study. This was a 2 versus 3 dose immunogenicity trial, and I've listed the 3 doses here. There was 1 experimental group. It was a group that received 2 doses at 0 and 6 months at 9 to 13 years. And there were 2 comparison groups that received 3 doses, 1 in the 9 to 13-year-old girls and 1 in the 16 to 26-year-old women. And the main analysis was a comparison of the 2-dose 9 to 13-year-old group with the 3-dose 16 to 26-year-old group. And in this comparison, non-inferior criteria were met, and the antibody response was higher, actually, in the 2-dose 9 to 13-year-old group. And then in the analysis comparing the 2-dose and the 3-dose schedules in the 9 to 13-year-olds, non-inferiority was lost for HPV 18 by 24 months and for HPV 6 by 36 months. Now, this shows the status of regulatory approval and recommendations for 2-dose schedules. We talked about this as well. HPV bivalent and quadrivalent vaccine have regulatory approval for use in a 2-dose schedule among young adolescents from the EMA and also in a variety of countries. The World Health Organization changed its recommendations for vaccination in 2014. A 2-dose schedule is recommended if the vaccination schedule is initiated prior to 15 years, and a minimal interval of 6 months is recommended between doses. And a 3-dose schedule at 0, 1 to 2, and 6 months is recommended if vaccination is initiated on or after 15 years. A variety of other countries have also made recommendations, but several countries recommended a 2-dose schedule before the WHO recommendations and regulatory approvals, and more are changing to 2-dose schedules. In the U.S., we do not have, there have been no submissions to FDA for 2-dose schedules, and for both the bivalent and the quadrivalent vaccine, there are no plans for submission to FDA. And for the 9-valent vaccine, for which we heard data in the previous presentations, there are no data on 2-dose schedules in the BLA currently under consideration by FDA, but a trial comparing 2-dose and 3-dose schedules has been initiated by the manufacturer. This is a review of that trial. It's an immunogenicity trial. It started in December 2013, and according to the clinicaltrials.gov website, the last visit is scheduled for July 2015. There are 5 arms in the study. There are 3 experimental groups that are getting a 2-dose schedule. 2 are getting a 0-6, one's getting a 0-12 interval in 9 to 14-year-old girls. And there are 2 comparison groups that are getting a 3-dose schedule and the standard schedule of 0-6, one in the 9 to 14-year-olds and one in the 16 to 26-year-olds. With that background, I'm going to move on now to talk about the issues and options for recommendations that have been discussed by the work group. So as I mentioned, we have 2 things that are influencing our discussions. One is the expected licensure of the 9-valent vaccine, and the other is the status of data on 2-dose schedules. We've discussed 2 different approaches. One is to consider 9-valent vaccine as a 3-dose schedule and wait to consider 2-dose schedules when data from the 9-valent 2 versus 3-dose trial are available in about a year. The other is to consider 2-dose schedules for bivalent, quadrivalent in the 9 to 14-year-olds now based on available data. Before I get into the specific recommendation issues, I want to just reiterate some things that have been discussed already. One is that the BLA for the 9-valent vaccine that was submitted to FDA in December 2013 and for which we expect licensure at the end of this year contains data from a 3-dose schedule in females 9 to 26 and males 9 to 15. We expect that the quadrivalent vaccine will likely continue to be available for 12 to 18 months after the 9-valent vaccine is licensed. Of course, this differs from the PCV7, PCV13 transition. The work group discussed the 9-valent vaccine for the currently recommended ages for females and males. However, use in males older than age 15 would be off-label initially before the older age group is licensed. But immunogenicity data in males 16 to 26 are available and were presented to ACIP today, and you all saw those. Compared to the quadrivalent vaccine, we also heard that 9-valent vaccine would provide very little additional benefit for males. However, programmatic issues were considered for the age groups for male recommendations by the work group, and this includes the issue that stocking of different vaccines and the fact that eventually it would be licensed in this age group. So that was a consideration taken into account by the work group. So again, for the first option, which is to consider 9-valent as a 3-dose schedule and to wait to consider 2-dose schedules when 9-valent data are available from the trial. This is some draft wording which shows a little bit what this option would look like. The first 2 bullets here are just our current recommendations for the routine age group and also for the recommendation for those who are not vaccinated at the recommended age group. The third bullet in bold would be the new wording, and here the wording would be something like vaccination of females is recommended with bivalent, quadrivalent, as long as this formulation is available, or 9-valent vaccine, and vaccination of males is recommended with quadrivalent as long as this formulation is available, or 9-valent. And then the last bullet is just our recommendation for the spacing of the 3 doses. This in table form shows what this option would look like. Here I'm showing the routine recommendation and the recommendation for those not vaccinated at the routine age group. So for males and females 11 to 12, we have the 3-dose schedule, and also for the those that were not vaccinated at the routine age of 3-dose schedule. And then for males and females, we have listed which vaccines could be used. And then at the bottom of the slide, as well as subsequent slides, is a bullet just to indicate for the committee members that in this recommendation, 9-valent vaccine would initially be off-label for males older than age 15, but we do have data available. There's a lot of other wording, of course, that would have to be drafted, but I wanted to show this wording that would explain the differences between the vaccines, and the wording would be something like bivalent, quadrivalent, and 9-valent all protect against HPV type 16 and 18 types, which cause about 66% of cervical cancers and the majority of other HPV attributable cancers in the United States. HPV 9 targets 5 additional cancer-causing types, which account for about 15% of cervical cancers in the United States. HPV quadrivalent and 9-valent vaccine also protect against HPV type 6 and 11 types that cause genital warts. For protection against genital warts, in addition to cancer-causing HPV types, vaccination is recommended with quadrivalent or 9-valent vaccine, and when quadrivalent vaccine is no longer available, 9-valent vaccine can be used to complete a series begun with quadrivalent vaccine. And this would be similar wording for both of the options I'm going to show you. So the second approach would be to consider 2-dose schedules for bivalent, quadrivalent vaccine now for 9 to 14-year-olds based on available data. I want to mention that we haven't done grade for this, although WHO has done grade, and I've shown the link on this slide to the grade that was just recently posted for their evaluation. So if we consider 2-dose schedules for bivalent or quadrivalent vaccine, we have a variety of options when 9-valent vaccine is licensed. One is to recommend 9-valent as a 3-dose schedule, and the work group did develop some wording for that particular option. The other is to recommend 9-valent as a 2-dose schedule, and the third would be to postpone a recommendation for 9-valent vaccine until the 2-dose trial results are available at the end of next year. So this is the wording for option 2. Again, the beginning, the wording for the routine recommendation ages would be the same, and this first bullet is the same as well, which basically says that either of the 3 vaccines could be used. The middle bullet here would be the new wording, and this would say if the vaccination series is started with bivalent or quadrivalent vaccine before age 15 years, a 2-dose schedule is recommended at 0 and 6 months. And if the vaccination series is started with HPV 9 before age 15, a 3-dose series is recommended. If the vaccination series is started at age 15 years or older with any HPV vaccine, a 3-dose schedule is recommended. And this table, this is in table form, the recommendation which I just read shows again the routine and for those not previously vaccinated. So for the routine for females and males 11 to 12 years, bivalent or quadrivalent 2 doses and 9-valent 3 doses, and the intervals are listed. And then for those not previously vaccinated, those 13 to 14 would have the same schedule options as the 11 and 12, but those 15 to 26 females and 15 to 21-year-old males would need a 3-dose schedule similar to the one we're currently recommended. Again, in the bullets below, just to remind people, in this scenario, it would be off-label for 2-dose schedules for bivalent, quadrivalent vaccine, 9-valent vaccine for males 16 to 21, and data are available for all schedules and vaccines, however, which we haven't graded yet for all of these. I want to mention a variation for option 2, and that is to recommend what's called an extended schedule for the 3-dose schedule for the 9-valent vaccine. This would also be off-label, but it would allow the interval between the first and the second dose to be the same as the interval between the first and the second dose for a 2-dose schedule. And that would again apply to the 11 and 12-year-olds and the 13 to 14-year-olds. 15 to 26-year-olds we have on this table listed in our traditional schedule. And again, this would be off-label for bivalent, quadrivalent vaccine and the 9-valent delayed schedule, and the 9-valent vaccine males 16 to 26 years, and then no data are available for the 9-valent delayed schedule. We have presented data for a quadrivalent delayed schedule to ACIP previously. So there's pros and cons to each of these, some things to consider for option one. Of course, the work group really felt this was the simplest. We're just kind of inserting 9-valent vaccine as an option into our current schedule, and then we would reconsider 2-dose schedules when we have data from the trial, which presumably, if it looks good, will be submitted to FDA. So the work group felt this would cause the least confusion. For option two, of course, there's a lot of interest in 2-dose schedules. These could facilitate delivery and decrease resources. There were concerns about potential confusion for providers and the public, different schedules for different vaccines, and then frequent changes in recommendations. Something that was mentioned by Dr. Person is the potential differences in duration of protection for 2 versus 3. This is an outstanding question for the 2-dose schedules. This would apply to any time we went to a 2-dose schedule. And of course, the 2-dose schedule would be off-label, as I mentioned before, and there are no plans for bivalent and quadrivalent vaccine for submission to FDA. So with that, I'm going to turn this over and ask, are there other recommendation options that ACIP members would like to consider? What other data would ACIP members want to see before February or at the February ACIP meeting? And which option do ACIP members prefer?
So with that, I think we open up to any comments from ACIP. If you could put up the options again. And Dr. Vasquez.
Yeah, I have a question, and pardon if you went through this and I missed it, but what about individuals who were fully vaccinated with the quadrivalent?
Well, this is what you're talking about is the question was asked earlier by Dr. Ornstein about revaccination.
Right.
Is that we have not, the work group is not enthusiastic about revaccination recommendations. One is that we are still exploring some of the cost effectiveness, but as was shown by Dr. Person, it really doesn't look cost effective in the most favorable scenario, and we feel that resources should be spent on trying to get enough more people vaccinated. So we've not decided not to make a specific recommendation at this time about that.
Dr. Harrison.
I'll just state simply that I like the simplicity of option one.
Dr. Kemp.
I agree, and also I want to just point out the fact that I think it's we can't really, or it would be extremely difficult to ignore the 9-valent vaccine and not make a recommendation about that. So if that's the case, then we are talking about potentially 3 different vaccines with different dosing patterns, which I think is going to be very, very difficult.
Dr. Bennett.
Yeah, I would tend to agree with the simplicity argument, but also my concern would be that if we went to option 2 and then the 9-valent study that's being done showed inferior immunogenicity with 2 doses, we'd be really stuck with that forever. So I think in terms of a pathway, what we really want to get to is implementation of 9-valent and then figuring out the number of doses.
Ms. Pellegrini.
I'll get back on my scheduling hobby horse here. So I think for providers, there is simplicity to the 3-dose schedule. For families, there is less simplicity to a 3-dose schedule than a 2-dose schedule. I think there's also the consideration that if we recommend 3 doses, we have to be cognizant of the fact that we'd be coming back maybe a year later and saying, oh, we changed our minds, 2 doses is fine. And that has, implications, I think, for how people view our work, rightly or wrongly. So we have to be very aware of that family perspective here.
I'm going to pick up on that point a little bit and just say that eventually I can really see a benefit in leveraging the biology of younger people into something that has profound effects. If I approach my patients, parents, and so on, and say, if we can start this before the age of 15, you only need 2 doses. If we wait until after, you're going to need 3. That is a powerful message, and I think we would see the ability to raise rates quite profoundly with that. Dr. Bennett?
Can I just ask a clarifying question? So are you both saying that we go out of the box with only 2 doses for 9-valent?
I think I prefaced this with eventually. I would like to see that. I think we have to, for reasons out there, be very careful to not pre-anticipate the results of studies being done. So I think we have to be careful along that line. But if such results are out there, I would be very proactive in making things that really, as Ms. Pellegrini has said, have a lot of benefit for families. Dr. Stuckett.
I just want to remind people that the results that might be forthcoming, a year or so from now, about a 2-dose schedule will be about a 0-6 month interval, not about a 0-2 month interval. So in addition to whatever sequencing and timing you think of, I don't think the science suggests that 0-2 is the same as 0-6.
Dr. Kemp and then Dr. Ellie.
Yeah, just following up on what Ms. Pellegrino said, I really agree that this could be a very strong leverage, having the option of 2 doses if you start early. And I also really agree that flip-flopping a lot on recommendations destroys credibility a little bit. So that's why I think that's a strong case for why we go with the 3-dose 9-valent and then hopefully make the transition as quickly as possible to 2-valent with the 2 doses with the 9-valent.
And Dr. Ellie.
The only other thing I was thinking of in my concern about going to 2-dose now is obviously, as everyone has said, the question is that really the appropriate thing to do and wait for the studies to be done? But also, it's not clear to me that we'll have any idea of the length of protection from 2 doses, right? So wouldn't it be awful if we then went back to people and said, by the way, it doesn't actually last as long. So now you've vaccinated 9 and 10-year-olds, and so there's a few more unknowns, I think.
Ms. Pellegrini.
Sorry, I just want to be clear that making recommendations with little or no evidence would always be my last choice. But we do have the prospect of having evidence in the not too distant future, which I'm not trying to say we should, as you said, presume what that evidence is going to be, but build into our recommendations the recognition of that and perhaps telegraph strongly that changes may be coming soon.
Dr. Engel.
Well, I also like the simplicity of the first option, but I would point out we don't know the duration of protection of a 3-dose schedule either.
Dr. Karen?
Just along those lines, I think when thinking about HPV vaccines, to me, there's always a question of what we can assume by inference from 4-valent versus 9-valent. I'm not personally convinced that we would need to wait for long-term duration data for 2 doses to be able to move to a 2-dose schedule, and we might be able to use by inference data from the quadrivalent vaccine to think about that. But obviously, I agree that it would be helpful to have the initial efficacy data from the 2-dose schedule for the 9-valent vaccine.
And Dr. Belanja.
Yeah, I thought the incremental cost effectiveness analysis was very helpful, and I believe that was done on 3 doses. And if I recall correctly, it wasn't particularly sensitive to the duration of protection, but I'm not sure if I got that right or not. Maybe the presenter can clarify that.
I think that's correct, but Mark?
So we're assuming that the duration of protection was the same for the 4-valent and the 9-valent.
Okay.
It wasn't sensitive to that assumption.
Great, thank you. So I agree with the previous comments. I think, it would be great to be able to go to 2 doses, but the science isn't quite there yet.
Dr. Middleman.
Hi, Amy Middleman from SAM. I just want to point out, I think it's important to recognize that among those who start the HPV vaccination series, the majority do complete it. And so I'm not sure it's 3 doses versus 2 doses that should become a major issue. It's how do we get people to start the series? Because when they start the series, they usually finish. And I would also just mention from an historical perspective, and I don't have all of the data, so someone who does could probably help, but there was a 2-dose recommendation for a specific age group for the hepatitis B vaccine for one of the products, and I think it became very confusing, and I think we need to remember what the sort of historical perspective is. I don't know how often that was used for those who were between a certain age group who took a certain product of hepatitis B vaccine, and most providers just really wanted to know the one-on recommendation. So I think these are important things for us to just consider as we move forward.
Dr. Shuckett.
Yeah, I was just going to remind people that in the early days of HIB, we had a 2+1 and a 3+1. You know, we had different vaccines with different schedules that providers jumped on because they were so enthusiastic about effective HIB vaccines. So they've done that before. It doesn't mean that providers who care for adolescents are comfortable with it.
I think there's also need to better understand why we have only 50% of potential recipients choosing to get that first dose. I agree fully with you that once that first dose is given, but at the end of the day, that's only 1 out of 2 people. And the other concept, I think, is I'm much more interested in having that first dose be provided at age 11, 12, or 13 than I am at age 18, 19, or 20. So there are some profound effects in terms of how we can market. And it's not our job here to market vaccines, but I think it's our job to really keep in mind what the practitioners are facing day in and day out and trying to implement our recommendations. Dr. Pickering.
Yeah, Laurie, two questions. One is, in several areas you mentioned off-label use of various vaccines. It would help to know whether those are studies being done to clarify that they wouldn't be off-label eventually. In other words, are these off-label now indications that you mentioned or possibilities that you mentioned? Will we have data in the future that they won't be off-label? And secondly, will we have any data about the 2-dose 0 and 12 months 9-valent vaccine, because that would fit in nicely with the yearly recommendations that adolescents have for their visits.
Let me put this up again, because the trial that's being done right now with the 9-valent does have a 0-12 month arm in it, so there will be data. And also, one of the trials that was conducted with the bivalent vaccine, which is not published yet, which has been presented, also had a 0-12 months. Most of the studies have been a 0-6 month. But so we will have data on the 9-valent, and there are data available for the bivalent, which shows the 0-12 months looked about the same as the 0-6 month. So they were both non-inferior to the older women. That's only been presented at a meeting. And then the reason I was highlighting in the tables what was going to be off-label is I wanted to let the ACIP know that in any of the scenarios we're proposing, there is at least one off-label recommendation, mainly because unless the ACIP would like to recommend in option 1, which is the simplest, which we're talking about right now, in option 1, if we didn't want to have an off-label, we'd have to recommend the quadrivalent vaccine for 16 to 26-year-olds. So I just wanted to let people know that even in this, our most simple recommendation, we will have an off-label, but that's temporary because Merck is likely going to be submitting the data we saw today to FDA, but it would take the usual amount of time to get that license. So in all of these, there is some. So the 9-valent in the older males will be off-label temporarily, but from what we understand, if we did recommend a bivalent or quadrivalent 2-dose schedules, those would be off-label because for the schedule, because the companies are not going to be submitting any data to FDA on the bivalent and the quadrivalent vaccine.
Other comment? I know that Dr. Schaffner has a comment, but before we get to your comment, Bill, have we given you sufficient feedback
Yes,
for
I wanted to understand a little bit more about the comment that was made about giving people some foresight into what's coming and how you recommend doing that.
I'd be delighted to discuss that offline.
Okay.
I was glad to hear everybody talk about pragmatic things, and I think one of the pragmatic things that gynecologists have to deal with every day is we're not really seeing patients in the earliest teen years. We're usually seeing them later, and if a 2-dose schedule's out there, the payers are going to say we're only paying for 2 doses, and people are going to leave the office with 0 doses if they think they have to pay for the extra 3rd dose. I mean, we just had a discussion yesterday about how payers won't pay for a flu vaccine during pregnancy. So we're going to have the same situation, unless the payers that you deal with are much more sophisticated than the payers I deal with.
Well, while we have you on the microphone, to Dr. Ault, I know there's been some changes recently in terms of some of the recommendations out there for the quote-unquote annual gyne exam. But for your organization, how common is it for women to be coming in on a annual basis, i.e. every 12 months as opposed to sporadic visits in between?
Well, there are still recommendations about mammography and breast exam and blood pressure checks for people on oral contraceptives and pregnancy planning and a bunch of other things that probably get short shift during the annual exam when we were concentrating so much on the pap smear. So that concept's certainly out there. It's being reviewed by ACOG. The well-woman visit's being reviewed by ACOG, but certainly immunizations is something that we could do better as a specialty too.
And I think, and I'm just so you're informed, we don't have any public comments scheduled, and we're trying to keep within our time limit here, so as not to delay people out. But I'm curious also on both AAFP and AAP in terms of your abilities to right now carry out the current 0, 1 to 2, and 6-month versus a schedule that would, for example, be 0 and 12-month.
So Jamie Lair from the AAFP. Logistically, I've turned it into a 0, 6-week, and 6-month schedule. It's the 2 6s make it easier for my staff and the patients to remember. The 6-week is actually very easy for people to come in for because it's not that far away. The 6-month is actually much harder, and that's the one which usually gets caught up at the next well child check when they say, oh, you haven't had your 3rd one, come on in.
David Kimberlin, AAP. Clearly, 2 visits would be simpler than 3 for an adolescent. That said, I believe the AAP would rather wait for the data that are pending before going there. The stutter step of let's do this, let's do that would be suboptimal compared with waiting a little while and getting the actual data that can drive the discussion and the decision.
So I think there seems that there's been a consensus here that there's something that we would strive for in the future, but until such data and evidence is available, that we're hesitant to take that leap. And so we're going to have some incrementalism perhaps, but it will be evidence-based incrementalism, if that's it. Dr. Middleman, for the adolescents.
I just want to make sure I wasn't misunderstood. I just want to make sure that Sam would agree with that process. The concern about 2 doses for one product at one time is the issue, and I just wanted to make sure people were clear on our position on that. Thanks.
And Dr. Merkowitz, does that help clarify?
Yeah, thank you very much.
Other comment? We now will turn it over to Dr. Schaffner.
Thanks, John.
On behalf of the National Foundation for Infectious Diseases, I'm pleased to announce a new call to action from NFID and the Council of State and Territorial Epidemiologists that urges healthcare professionals to be stronger advocates for HPV vaccination. A hard copy of the report was included in the packet for ACIP members and liaisons, and additional copies, if they haven't all been scarfed up, are on the handout table outside the room. It's troubling to NFID and to me personally, and I hope to all of you, that extremely effective HPV vaccines are available but still underutilized, leaving adolescents vulnerable to HPV-related cancers. The call to action is supported by many professional organizations. Among its conclusions, quickly, healthcare professionals need to recommend HPV vaccine with the same strength and conviction that they recommend other adolescent vaccines. Same day, same way. It's their responsibility to educate themselves and everyone in their practice about HPV and the benefits of vaccination so that positive messages reach their patients and, of course, parents. And finally, a drum we beat often, they need to make HPV vaccination routine and eliminate missed opportunities. First dose coverage in girls and boys 13 to 17 would reach over 90% if they received HPV vaccine at the same time they received other recommended vaccines. The call to action is available on NFID's new HPV Resource Center. The website is available right in the document here. The Resource Center includes tools from a range of medical organizations to help healthcare professionals improve HPV vaccine delivery. And then finally, NFID and CSTE will be hosting a series of webinars, with the first scheduled for November 4th, to share the report and its findings. Information about the webinars and a link to the register is available at the HPV Resource Center. Website address is in the report, and on a card, some of which may still be on the handout table. Thanks.
Thank you, Dr. Schaffner. Any further comment? And seeing none, I just want to send you with happy 50th birthday for Nassi and our neighbors to the north, and happy 50th anniversary for ACIP. Travel safely, and we'll see you back in February.